Okay, let's take a look at multithreading in Aegis and webassembly and how the two are related. So let's just take a look at the sample app that loads when you bring up Aegis. By the way, to do that, we can go to Aegis host rather. In the Module Federation repo, and then you can open the application in Gitpod. Just continue with your GitHub ID. Okay, you can run this in your local client VS Code or in the web version. So right now it's going ahead and installing it. If there are pre-builts, often there are pre-builts, this process is much shorter. In any event, we're not going to wait for that. So, I'm just going to clear this. And we see here that there's 3 models that have been loaded. And, okay, we can post, we can get. And we can also now I've exposed the hot reload function. So if we want to, we can reload orders to pick up any new changes. And we should get back that message. And so it's talking about thread pool. Okay, so what's that? Thread pool. What we've done in Aegis is for each model, we've created a thread pool that allows you to have models or applications completely separate and distinct from one another. So there's actually zero impact. There's a shared web server, HTTP server, Express, in the main thread and in the worker threads, as they're known. Those are running the models, the individual applications. So like any thread pool, you can set a min and a max. We track like how fast are we queuing jobs. How many queued jobs will we accept before allocating another thread if another thread's available. How many jobs are waiting for a thread. How many threads are available, that kind of thing. Is the pool open or closed? That means if the pool is closed, that means we're draining the pool because we're going to restart threads. We're going to shut down the current threads, and that's because we're doing a reload. We're deploying new code, and so down here you can see we've reloaded this pool 3 times. All right, so let's take a look then at this third object, wasm. So I hit post, but you can see that there's a deployment running, and that's because that thread pool, like you saw on the previous screen, wasn't loaded. And that's because we chose not to do a preload, right? You could preload the pools, which means that they'll load when the application boots, when the application comes up. So you can either do that or not. And if you don't, then it's going to load up on the first request, like it did here. And so we can look at how these thread pools behave. Let me go back and show that now we have two, right? Let's look a little bit at how they behave. So if we switch back to orders. So orders, this is just a vanilla JavaScript object. And just for testing purposes, we have outfitted it with a Fibonacci sequence, just to do a couple quick comparisons. So really, like if we look for the 45th number, well, let's just do 21st. Right, so we can see that right now there's no result, there's no time. If we say that we want to run this command, however, then you can see we get back a result and a timestamp. This is how long the operation took, how long it took to run to the 20th number. So let's do 45 and check that out. You can see that's not coming back right away, and I can pump in a bunch of transactions in there though, and there's no delay, even though I haven't got my answer back, because we're multi-threaded. And I'll show you in the wasm thread, which runs this much faster, how that works. Just looking to see if that came back. It didn't. Okay, so you can see our max is 2, our min is 1, and right now our total is 1. Okay, so we didn't get that Q rate above the tolerance level, so we can try that again. Let's ask for that Fibonacci number. Okay, and now we can see that this is stalling. I think I just didn't hit the button before. And that should have done it for us. Yeah, there it goes. Okay, so key rate rose to 49%, at which point we activated another thread, so there's now 2. And we caught this just in time to see that the other thread was still running the Fibonacci, right? So at that point, the event loop's completely blocked. And if that were on the main thread, right, the entire application would be unresponsive. Whereas now the main thread, all it's doing is I/O, and it's just doing I/O back to the either to a thread, running a thread, or queuing a job, right? So it's never going to be the event loop is never going to be blocked. All right, and now let's see here. We've got total still 1 thread on in the wasm thread pool. So let's. By the way, what was that answer? I have this up here. Results. So that took about 14 seconds. Let's see what wasm does for the same value. 45. We'll run Fibonacci there, and we're also going to post in a bunch of requests. Okay, and there it goes. Let's just see how fast that ran here. You can see that's about half the time. It was about 7 seconds. So wasm twice as fast there, which is what we expect. Let's go to now. Just check that the thread pool did what we thought. Okay, so we exceeded the queue rate, so we activated another thread. So now there's a total of 2 in that pool. Okay, so that's a pretty good quick review of kind of the latest and greatest stuff that's in Aegis.